Okay, physics people, I have to get that out of my mouth here. I was all excited about this problem during class, but I made the erroneous assumption that we start at ground zero and end at ground zero. I went ahead and I did the quadratic here because we're coming up with this weird time and a negative value for your y distance. Well, it comes out that this is not, in fact, the case. That was a bad assumption on my part. So if you go ahead and write out the equation for your y value, v0 sine theta, that's your y velocity times time minus 1 half gt squared, and you rearrange it to put it in standard form, you can find the axis of symmetry using negative b over 2a. And if you do that, negative b over 2a, you're going to go ahead and get uh, negative b is negative 0.75 divided by negative 9.8. And when you do that, you come up with a number that works. So we have 0.75, 9.8, and that is the time is 0.0765 seconds. So really what we're seeing, and I'll show you in just a minute on Desmos, we're seeing that this is not the case. It's not symmetrical here. As a matter of fact, we're going to see that the 1.3 continues down like that, and it's way over here somewhere. So we're only looking at that part of the thing. It's almost like if you're shooting it off and now it's going down. So anyway, let me show you a calculus way to do this. Calculus way is if I go ahead and I take the first derivative of this quadratic, okay, and set it to 0, that will enable us to get the maximum. So let's do this. Go y prime is equal to negative 9.8t plus 0.75. Now, if you set that equal to 0 and solve for the t, that will give you your maximum. So that's going to be negative 9.8t plus 0.75. I'll bring the 0.75 over to the other side. Negative 0.75 divided by negative 9.8 equals t. And of course, that's the same that we saw up there. Now let's take a look at the curve as I plotted it on Desmos, and I'll show you my erroneous thinking. So let me see if I can do that here. Okay, here we see that quadratic plotted. And notice, if I bring it up like this, the part that's symmetrical here is going between 0 and 0.153, which is a far cry away from 1.3. 1.3 is going to be somewhere let me see here on the x. So that's way over here, way down. Let's see if we can bring it here. 1.3 is way down here someplace. So you can see, well, let me see if I can get it here. This is pretty close. Oh, come on, why isn't it doing it? So you get the point. So I was erroneous in making the assumption that it started and landed at the same place. Once again, learning curve, and I shouldn't make an assumption.